In Unit 12, we're going to be dealing with something that you learned about in Advanced Math 8, parabolas and quadratics. This is something that most of you covered last year. Now, I do not think that you made the connection, but that I'm hoping to make in this section. That's why there's so much writing here on this very first section. What I looked at when I gave you your packet is I have notes for each of the sections, except there are going to be some additional worksheets I realized after talking to Mr. Vang this morning that I'm going to have to add some other things about vertex form that is not in the packet that we need to talk about. So, in section 1, we're going to be talking about quadratic functions. If you don't know what a quadratic function is, it is something that is raising a variable to the second power, not the third. There might be an additional x there, and there's sometimes a number in front of these x squareds or negative x squareds or things like that. But that's what we're going to be dealing with. And the two forms that we're going to be dealing with are standard form. This is in standard form right here. This is vertex form. The packet that I gave you does not do a good enough job of teaching you vertex form, so I'm going to have to do something. After I made all the notes this Easter break, I realized that, hey, this is really short and it needs some work, so that way you guys get more practice. We're going to spend a lot of time today dealing with this stuff over here, but you won't have enough practice with that, which is something that I'm going to have to add to your packet. If you don't remember what a quadratic function is, in Advanced Math 8 they called them U-shaped graphs, but I don't really like that. If I think about a U-shape, I think of a U. I do not want you to think that these two things are parallel to each other. The bottom is rounded, but a parabola actually opens up and goes to the right and opens up and goes to the left or goes down. If it's a function, it opens outward. It gets wider as it goes outward. So that's why I put down that it's a U/V shaped graph. At the bottom, it's usually rounded, and it always gets wider as it gets taller or shorter. That's what I mean by that, U/V shaped parabolas when it's graphed. You are going to be asked to solve quadratic functions, and that's where it touches or intersects the x-axis. That's what it looks like graphically. We're going to not do a lot of graphs in this worksheet that you have today, but I want you to know what it is, because when we get to the graphing part, that will hopefully make a connection between what we're doing here versus what we're going to do later. And I have to bring in my AMA background. My AMA background says that if I don't tell you that these are also called solutions or roots or x-intercepts, then I am not doing you justice. So we're finding solutions, we're finding roots, we're finding x-intercepts. That all means the same thing. And we're going to give our answers in a solution set bracket. These are called curly braces. And if you wouldn't mind giving them in order from least to greatest, I would appreciate it. That is the way they write it on the SATs. It's the way they write it on the SBAC. And so I'm going to try to get you into the habit of doing it from least to greatest. If you did not give it from least to greatest, I would still give you full credit, because a solution set means the solution is inside these brackets. So that's fine. If b is equal to 0, what am I talking about? I'm talking about if it's in standard form and there is no b, there's nothing in front of your middle term. The easiest way to solve it is by square rooting. We're going to do a lot of this today on this first worksheet. And when you square root a variable squared, it is the same thing as an absolute value. Mrs. Jarvin is the one who really pounded this into my head. When we teach it, we have to make sure we're letting them know that this is the same thing as this. And it took me a while to go through Desmos to look at something squared, square root, look at this graph, and then look at this graph, and then you realize that they are the same graphs. Matter of fact, if I were to give you another example, Let's do x minus 2 in parentheses squared is the same thing as that. Those two things produce the same graph, and if you ever want to play around with it, go to Desmos, punch it in, take a look at it, and you'll see that those are the same thing. So when we ask you to square root something squared, don't forget that there are two possibilities, a positive possibility and a negative possibility. When you square root something squared, do not forget that there are two possibilities. You're going to put a plus or minus sign as you're square rooting. This is like one of those things that I wish I could put a little star next to in my notes or in your notes so that you remember it, because a lot of students forget about that. And what we're really doing when you think about it is something like this. X squared is equal to 4. 2 times 2 is 4. Is that the only possibility? Negative 2 times negative 2 is 4. So if you think about a positive times a positive is still equal to a positive, and a negative times a negative is equal to a positive, there are two possibilities for something squared equaling a positive value. That's why we have to put plus or minus signs when we solve these things. For right now, the square root of a negative number is not a real number. We're going to put no real solution, or we can use the symbol for no solution, which is this 0 with a line through it. These are actually called imaginary solutions or imaginary numbers, and as a matter of fact, you get to learn about it in Honors Math 2 in section 12.4. We're going to cover that on Thursday of this week. So, but for right now, for sections 1, if you get something like this, put no real solution, or you can use the symbol, which means no solution. Lastly, if b is not equal to 0, I would set it equal to 0 and I would factor it, and I put down where we did factor, and we did it in the 1.2 through 1.6 notes. I'm not going to cover that here. If you need to refer back, I kind of forgot how to factor, then your notes are from these sections. I'm hoping you still have them. And if you don't have them, don't forget my website has all the notes for the entire semester on there, and there's only videos for second semester, but I plan on fixing that for next year. Okay? And use the zero product property, which came from 1.7. X-intercepts, we usually write it as at coordinates like some value, comma, 0. Okay, so with that being said, we have 1, 2, 3, 4 examples that we're going to do, and you are welcome to do them on a separate sheet of paper, because remember, we're not writing in the packet anymore, and you can skip some space if you would like to, but here are some examples for us to do. Number 8. Solve each equation, factor or square root. So if you have this, there's pretty much two scenarios. Does the b equal 0, or does the b not equal 0? That's kind of what I do when I look at these. And if you don't know what I'm talking about when I say does b equal 0 or b does not equal 0, I'm talking about when it's in this form, when it's in standard form, the value in front of the x, not the x squared, just the x. Not in the value in front of the m squared, the value in front of the m. This is your a. This is your b. This is your c. And even the b has that negative involved right there. This is your a. This is your c. When I ask you to decide, you're looking at the b value. The b value is negative 30. It's not 0. In my directions, if b does not equal 0, solve by setting it equal to 0 and factoring it. And we're going to use the zero product property. So my b is not equal to 0. Is this already equal to 0? Good. If it's not, you might have to subtract things over to set it equal to 0. You might have to move some things around. That's a possibility. After that, the first thing that I would try that we learned way back in the when is there a greatest common factor? If there is a greatest common factor, tell the person you're sitting next to what is the greatest common factor. What's the greatest common factor? Tell your partner, please. Good. I heard a lot of people say 2. I would factor out a 2 first. Then what you have left is something that looks like this. And then this is where the rubber meets the road. That's an expression us old-timers use as to describe, okay, let's find out what you're made of. Let's see who remembers how to factor, because this is guess and check. I don't know if you remember that section, but it's way back in 1.6, and we literally learned it in September of last year. So just to remind you, if you don't remember how to factor this, you may have to look back at your notes, but I'm just going to go with this. I'm going to change colors here. I'm going to go to blue. And remember, what I'm looking for is what multiplies to be that first term. And I have a couple choices. I can do 4m times m, I can do 2m times 2m, or I can do m times 4m. Those are my choices for that first times the first. Then over here, last times the last should be a positive 9. I have a couple choices for that. I can do 1 times 9, I can do 9 times 1, or I can do 3 times 3. But what you're checking to see is you need the O and the I to add to be that middle term, that negative 15. So what we're looking for is which combination of these numbers will have the sum of the outside plus the inside equaling negative 15. Now, I don't really want to jump and give you this answer right off the bat, so let me ask you to discuss with your partner. If you know what the combination is, tell your partner what it is and how come. Let me give you about 60 seconds to do that. Discuss. Here's what I'm doing in my head, just so you can see. I'm kind of going like this and saying, okay, if I did this times this, what do I get? Put that in my head. And then I go, what is this times this? So let me just draw a little arrow and a little arrow. What do you get when you multiply 4m times 3? And I kind of keep that in my head. And then I do this. What do you get when you do m times 3? Is there a way to get to negative 15? What if it was like this and this? Would that give you negative 15? How could I get that? Let me put a negative there and a negative there. So automatically, I'm thinking 4m, m, negative 3, negative 3 equals 0. And I'm curious because you had a chance to talk to your partner. If you and your partner came up with 4m minus 3 times m minus 3 or m minus 3 times 4m minus 3, please raise your hand if you got that. I'm curious. Okay. What that shows me is about 25 to 30% of you remember this kind of factoring. The majority of you in this room will have to go back and remember how to do the factoring by guess and check. What are we checking? We're checking that the outside times the outside plus the inside times the inside, that sum will be that middle term right here, that negative 15. And ultimately, if I did 4m times m should give you the first. The last times the last, a negative 3 times a negative 3 should equal a positive 9. If it doesn't, it means you've chosen the wrong factors. Almost every single thing in this first section factors perfectly. The ones that don't will show up in the second section. The ones that don't will show up in the third section. When I say that, I'm saying 12.2 and 12.3. Okay? So now what we have? We have 2 times 4m minus 3 times m minus 3 equals 0, which means we can use the zero product property. If you do not know what the zero product property is, it means that if this times this equals 0, either 2 has to equal 0, or the 4m minus 3 is equal to 0, or the m minus 3 is equal to 0. One of those three situations must be true. They all multiply to equal 0. This is the only property that says they multiply to equal 0, then each of these factors must equal 0. Now let me ask you, can 2 ever equal 0? No. That does not provide you any solution. Can the 4m minus 3 equal 0? Yes. What does m have to be? You add the 3, 4m equals 3, and if you want m by itself, you would divide by 4. Running out of room here. Let me scoot that up if I can. Oh. There's my first choice of divide by 4, divide by 4. That's one possible solution. Plus 3, here's my other possible solution. And what I want you to get used to, because they do this on the SATs and on the SBAC, they put these in order in a solution set bracket from least to greatest. My two solutions are 3/4 and 3. A solution set bracket means my solution is either 3/4 or it's 3 or it's both. That's what that means. The solution is in here somewhere. Don't forget what we did. We checked the b value. We factored. We used the zero product property, and we wrote our solutions from least to greatest in a solution set bracket. That means in these curly braces. Okay, second example, number 20. Is there a b value for this one? This is in vertex form. If you look at the vertex form, let me go all the way back up here to the top. Here's my vertex form. Is there a b value that's here when it's written in this form? No. If there is no b value, or if b is equal to 0, there is no b value, or b is 0, then we can solve by square rooting. I want you to see how you can solve this by square rooting. I think it's a little bit easier than what we normally do. So here's what I want you to do. I'm going to subtract 8 from both sides. 8 minus 8 is 0. 0 minus 8 is negative 8 equals negative 2x minus 3 squared. The negative 2 is multiplying the x minus 3 squared. I'm going to divide by negative 2. Negative 8 divided by negative 2 is? Why don't you tell me what it is? Good. And now what we have is we have something squared equals 4. I want to get rid of this squared term. The opposite of squaring something is square rooting something. The square root of 4 is 2. The square root of x minus 3 squared is the same thing as the absolute value. Why do I say that? The only reason I say that is so that you remember this. X minus 3 is not just going to equal a positive 2. X minus 3 is going to equal plus or minus 2. And a lot of times I just put plus or minus right next to it. Just like that. I think it's easier to write it that way. If you wanted to split it up and write x minus 3 equals positive 2 or x minus 3 equals negative 2, you could, but I don't. This is the shortest way a lot of math teachers do it. I'm going to add 3. X equals 3 plus or minus 2. Since I can simplify that, I'm going to. 3 plus 2 is... And what's 3 minus 2? And I'm going to put my solutions in a solution set bracket from smallest to largest. 1 and 5. What I like about this section is you can always check your answer. You can take the 5, you can plug it in. 5 minus 3 is 2. 2 squared is 4. Negative 2 times 4 is negative 8 plus 8 gives you 0. It works. You can plug in the 1 to see if it works. Plug in the 1. 1 minus 3, negative 2. Negative 2 squared, positive 4. Negative 2 times positive 4, negative 8 plus 8 makes 0. Both solutions, when you plug it back in, they check. That's a lot harder to do when you're plugging in a fraction, but it does work if you were to plug that 3/4 in, by the way, to double check. Number 22. Find the x-intercepts of a quadratic by setting it equal to 0 and solving for x. If there are no real solutions, then the equation doesn't have an x-intercept. Leave the answers in simplest radical form. Underline that. Is there a b value here? How are we going to solve it if the b is 0? If b is 0 and there's no b value there, I'm going to solve by square rooting. And so it first tells me, it even tells me how to start this problem. It tells me set y equals to 0, which is how we're going to do most of the problems. And b is 0. Okay, so I could try to factor this if I wanted to, but I'm not going to. Instead, I'm going to add 27. 3x squared equals 27. I'm going to divide by 3. And I know that 3 goes into 27 9 times. And I'm going to solve by square rooting both sides. When I square root both sides, the square root of 9 is 3. The square root of x squared is the same thing as the absolute value. And the only reason I share that with you is so that you remember that x is equal to either a positive 3 or a negative 3. And you could list these in order from smallest to largest. Or, if you want to, what some people do, which is what I do sometimes, is I put plus or minus 3 in a solution set like that. But I would also accept the old-fashioned way, which looks like this. I'm going to put or. This is what I prefer, though, just because it's shorter. Textbooks use it that way because it saves ink. Last one. You have 4 terms. Factoring review. Factor each expression completely. And so you may have forgotten how to factor when there are 4 terms. I'll give you a hint. It's way way back in about 1.5 and 1.6. That doesn't help me. Okay. When you have 4 terms, there is something called a certain type of factoring that we learned a long time ago. If you remember what it is, tell the person you're sitting next to. By grouping. There you go. So let's review. If you have forgotten factor by grouping and you need a review, please show me. Miss Promo, please show me that again. I forgot factoring by grouping. Okay, that's 50% of my class. There we go. The grouping method means that you look for a GCF out of your first 2 terms. Is there a GCF of your first 2 terms? What is it? For what? X squared. If you were to factor out a GCF of the first 2 terms, what would be left? Let's switch colors. Is there a GCF out of terms 3 and terms 4? What is the GCF? I'm not just going to use 9 because I don't think that would make things match. I want 3x minus 1 to be left over. I want the parentheses to match up out of this blue piece. What if I factored out a negative 9? Let's try that. Why did I do a negative 9? Watch what happens. Negative 9 times what gives you negative 27x? Negative 9 times what gives you a positive 9? The goal of factor by grouping is to make sure that these groups that we have here, this 3x minus 1 and this 3x minus 1, that they match. If they do not match, you cannot do the factor by grouping method. If they do match and they are the same, this is the same as that, you can now treat the 3x minus 1 as a GCF. You factor out the 3x minus 1. Well, what's left? What were the GCFs before that are still there? This 4x squared and the negative 9. So what we're going to do is we're going to put that in the other parentheses. Let's check by foiling. Does this times this equal your first one? Does that make 12x to the third? Then you do this times that. Does that equal your second one? This times that. Does that equal your third one? This times that. Does that equal your fourth one? If it does, then you have factored it correctly. You do not want to have 2 of these 3x minus 1s. There's only one of them because it's multiplying the 4x squared and the negative 9. Lastly, is this factored completely? Completely. Can, let's say, this red piece factor further? Is this a difference of 2 squares? If you've forgotten how to factor the difference of 2 squares, let's do that one. What's the square root of 4x squared? 2x times 2x is 4x squared. What's the square root of 9? I'm hoping you think it's 3 and 3. And because there's a minus sign, if we put a positive and a negative, that would multiply to be a negative 9, and the O's and the I's would cancel out. This is called the difference of squares. If it factors further, always factor it completely to get full credit. I'm going to stop your notes right there.